Artificial Intelligence Doctor. User question. What is the difference between output voltage and capture threshold in a leadless pacemaker and how they are correlated? Gemini AI answer. Gemini. In the context of a leadless pacemaker, output voltage and capture threshold are two distinct but highly correlated electrical parameters crucial for effective pacing. Here's a breakdown of each and their correlation. Output voltage. Definition: the output voltage, or pulse amplitude, is the amount of electrical energy, measured in volts, V, that the pacemaker delivers to the heart muscle with each pacing impulse. Point 1. It's the strength of the electrical stimulus. Purpose: the pacemaker is programmed to deliver a specific output voltage to ensure that the heart muscle is reliably stimulated and contracts. Point 2. Programming: clinicians program the output voltage of the pacemaker. Point 3. It's usually set to a value that is safely above the capture threshold to ensure consistent pacing. Capture threshold. Definition: the capture threshold is the minimum amount of electrical energy, voltage, at a specific pulse width, required to consistently stimulate or capture the heart muscle, causing it to depolarize and contract. In simpler terms, it's the lowest voltage at which the heart reliably responds to the pacemaker's impulse. Measurement: the capture threshold is determined through a threshold test performed by the pacemaker during implantation and at follow-up visits. Point 4. The pacemaker delivers impulses of decreasing voltage until it no longer reliably captures the heart, then increases the voltage until capture is regained. This identifies the lowest effective voltage. Variability: capture thresholds can vary based on the patient's individual heart tissue, the precise location of the pacemaker's electrodes, and even over time due to tissue changes or inflammation at the implant site. Correlation: the output voltage and capture threshold are directly correlated because the output voltage must always be set above the capture threshold to ensure effective pacing. Here's how they relate. Safety margin: to guarantee reliable pacing, the pacemaker's programmed output voltage is typically set with a safety margin above the measured capture threshold. Point 5. For example, if the capture threshold is 0.5 V, the pacemaker might be programmed to deliver an output of 1.5 V or 2.0 V. This margin accounts for natural fluctuations in the heart's excitability and ensures pacing even if the threshold slightly increases. Battery longevity: there's an inverse relationship between output voltage and battery life. A higher output voltage, further above the capture threshold, consumes more battery power, leading to a shorter device longevity. Point 6. Conversely, programming the output voltage closer to the capture threshold, while maintaining a sufficient safety margin, can extend battery life. Modern pacemakers often have auto-capture features that automatically adjust the output voltage to optimize for both reliable capture and battery conservation. Point 7. Optimization: the goal of pacemaker programming is to find the optimal balance, an output voltage that is reliably above the capture threshold but not excessively high, to maximize battery life and minimize unnecessary energy delivery. If the capture threshold significantly increases, e.g., due to fibrosis at the implant site, the output voltage may need to be increased to maintain capture, potentially impacting battery longevity. Conversely, a stable low capture threshold allows for lower output programming and longer battery life. In summary, the capture threshold tells the clinician the minimum kick needed to make the heart beat, and the output voltage is the kick the pacemaker actually delivers, always aiming to be strong enough to reliably capture the heart while being as energy efficient as possible.